Today's topic is actually the first of a 5-part series, and I call the series Zero to Zen. And some people have asked me along the way, they said, why do you call it Zero to Zen? Well, 5 years ago when I started using Tableau, I was at absolute ground zero. And this might sound kind of familiar to you because I started with a background in Excel. I was pretty good in Excel, a little bit of background in Access, but absolutely no experience whatsoever in visual analytics or the use of Tableau or any product like that.
Jim, just briefly, I think your video is pinned, so your shared screen is much smaller, and I don't think there's a way for any of us to make that bigger.
Double click that.
Yeah, it's just a little panel off to the side.
Okay, well, we're learning together.
I apologize for interrupting you. I just, if this is happening for me, then it's probably happening for others. I don't see any chats or questions about it though.
Will somebody in chat tell us if you can see the full screen?
And the full screen being
can only see me. Okay, we're going to try this again. I'm sorry. Nick, can they see us?
I think it's still you as the main forward. Is there a way to say your screen share should be full screen?
I am not seeing that. Hang on just a second.
Okay. So now I see both of us. Okay, now your screen appears to be the main view. And for those of you watching, there should be a full screen button off to the top right if you want to make his screen take up your full screen. Sorry, Jim.
No, that's fine. That's fine. Like we said, this is an all new experience for us on Remo, and we're learning along the way. I might be a Tableau Zen master, but when it comes to Remo, I am certainly not all that experienced. Let me pick it up where we left off. This is the first of a 5-part series. We're going to have one of these sessions each Thursday for the next 5 weeks. We're going to do it at noon Nashville time. Come, have a little lunch, enjoy yourselves. But during this time, what I want to go through is the experience that I had going from being a Excel, little bit of Access experienced engineer, really, a guy with no experience whatsoever in using databases, to the point now that I'm a 4-time forum ambassador and I'm a Tableau Zen master. What we're going to do over the next 5 weeks is we're going to look at these 5 topics. I look back after about a year of using Tableau, and I finally got fairly good at it. I look back and I said, you know, there were 5 basic concepts, 5 things that I really had to understand before I felt comfortable using Tableau. And today we're going to look at this first topic, that's data structures and connections, and how those data structures sometimes prevent you from doing the analysis you want and how data has to be restructured. Next week, we're going to look at probably the most important topic of the 5, and that's the order of operation and how the order of operation affects all your calculations and what you do in the viz. Then on weeks 3 and 4, we're going to double team here. We're going to do calculations and the language of Tableau, or the syntax of Tableau. Week 3, we're going to do relatively straightforward simple calculations and date functions. And week 4, we're going to do LODs and table calculations. And then in week 5, we're going to do what I call the toolkit. We're going to look at filters, sets, and parameters, because those are the things that you put in your dashboards and in your viz so that the user can make changes to the viz. And those 5 things together are what I needed to feel comfortable with before I felt really comfortable using Tableau. Let's get started with today's presentation. Today we're going to talk about data structure. And I don't know about where you grew up, but every household I was in, my households and for my kids, there was always a calendar on the door of the refrigerator. And I could look across that calendar. I could see, Tuesday, Wednesday, Thursday, and I could look down, I could see, weeks. And I could see that, in cell C3, I had a dentist appointment coming up in a couple of weeks. Well, I felt very comfortable with the idea of data being in a cell and that cell relating to everything that's around it. And that's really what Excel is. Now, when I started using Tableau, the first thing we learned was that Tableau doesn't like those wide, short data sets. It likes very narrow and very tall data sets. So whenever I get a new data set that looks something like this, where all these dates relate to one another, but they're all their independent measure, I know it looks like a calendar on my refrigerator. The first thing we got to do is we got to change the structure of that data set by pivoting it. Just highlight all the columns and hit pivot. Okay. And now the data is in the proper structure. And when we do that, we know that the pivot table names are really dates. So let's just change it to dates. And we have to recast it as a date also. And these are sales values. And once we've restructured the data, it becomes very simple to work with. We can add our dates, expand it out to months, add our customers, and add our sales to the table. And sure enough, we got a first data set into Tableau. And that was great, except I also knew that in the data that I had from my Excel sheet, I also had quantities that were associated with each one of those sales. And if I was in Excel, I know what I do. I just write a lookup function, and I pull the data from the second sheet back to the first sheet, and I have both quantity and sales on the same data sheet. Well, I started looking for a lookup function. Well, there is no lookup function in Tableau. Now, the way you do a lookup in Tableau is you create a join between the two data sets. And to do that, we're just going to bring our quantity file up to the canvas. And Tableau is going to join those two files together. And it's going to look and it's going to say, hey, wait, I know that the customers in your original file and the customers in the quantity file, I want to join on that. But we know also that they have to join on the date because the data is important. The data in one file has to equal the date in the other file. Once we do that, we can once again add our dates to the columns, expand it out, add our quantities, and sales. We get quantities and sales and everything's a line property. If you want to think back, take a step back and think about what we actually did, we added a second measure to our data table. And to do that, we did it with a join. Now that was great until the end of the accounting period. In the next accounting period, I got a whole new data set. And it had both quantities in it and it had sales in it, and I had to get it connected to the original data set. Well, in Access, what I would do is I just bring both files into Access and I do an append between the two. And that was about the limit of my knowledge in Access. But there's no way to do an append in Tableau either. Now, the way you do that in Tableau is you do it with a union. And we can union the data by opening the file itself. We're going to bring in our 2020 data. And create a union between the two. And when we do that, we can see we got a table name, and the table name in the two tables is different. I got the 2020 data and I got the 2019 data. So if I need to separate it back out, I can do it with the table name. And as long as we're here, we're going to bring the quantity data in. We're going to open the relationship box. We want to join the two files on customers. This is rather inconvenient, but this is the way it works. Then I got to come back a second time and connect the dates. Now in our example, we can put in the sales values and the quantities. Okay. So if you think about what we've done, we've gone through two different types of connections. We've gone through joins, which add additional columns in our data set. We've gone through a union, which increases the height of our tall, narrow data set. And those are the two primary connections that you'll use. The data connections that we've used and the join clauses have been very simple. And believe me, they get very complex in a hurry, and you need to spend time and work on them and practice them. But it's really not too much more than what you just saw. There is another type of connection that we also have to be aware of, and we use it from time to time. And that's what happens when you have data coming from two different data sources, or you have data at different levels in those two sources. And in those cases, you're going to use a blend. We're going to blend the two data sets together. Now, there's a couple things you got to keep in mind, and we're going to talk a lot about this next week when we talk about the order of operation. That blending always takes place it always results in an aggregation at the level of the link, or at the level where the two data sources are connected. And the other thing that happens is it always limits the functionality that's available for you in Tableau. Once the data are blended, you can no longer filter across the two data sets. You've already done that at that point, and you can't use LOD expressions. And to be honest with you, if there's a way to avoid blending data, I usually try to avoid blending data. I've got a couple data sets that I want to look at here. My first data set is nothing more than sales by quarter by category. And then I've got a second data set, which are goals by year. There are two different levels of two different levels of aggregation. One's by year, one's by month. We can bring them together using a blend. The first data I bring to the table, or sales, and that's the primary data set. The secondary data set is goals. But if we look at the data, we can see that something's wrong, because we saw that we had different goals in 2018 and 2019. So we can edit the blend relationship. These used to be called links, but now they're blend relationships. And I want to blend the sales data to the goals data, and we can see that it's already connected at category. And then to that, I want to come back and connect the links together. And you can see when we do that, we've got goals now that are by year, by category. So there's basically three different types of connections. There's unions, there's joins, which we'll use most of the time, and then there's blended data sets. And one of the things that we do, and when I say we, people who teach Tableau or train users in Tableau, is we always start out with what I call solid data sets. If you looked at the data sets that we were just looking at, they're fully solid. Every cell in that data set has a value in it, so it's solid, like our puzzle here. But in the real world, that's not how data exists. There's always gaps in the data, there's voids in the data, and sometimes the data is just really sparse. There's not a whole lot of data in the data set. And that's not because the data is bad data or dirty data, but it's a result of the source where the data was created. If you're familiar with ERP systems like SAP or Oracle, they're transaction-based systems. They're only going to create a record when a transaction happens. Like if there's no sales today, there's no record for today. And then there's other types of systems like third-party systems that were designed for a specific purpose, and they collect the data that they need to do the job that they're doing in their software, but it's not necessarily what you need to do the analysis from that data. Well, I want to take you through three different use cases today, where we can look at how we use data connections to restructure data so that we can answer the business question that you're faced with. Now, this first one we see all the time when people want to do a year-over-year analysis or a period-over-period analysis. We want to talk about how you can approach that by joining data. These last three examples come directly from the forum. They pertain to questions that we see on the forum really quite often. The first one is a classic problem. It's a two-date problem. You got a series of records. Each record has a start date and an end date. And you want to know what's happening in between those dates. The second is what happens when you have data that's part of a hierarchy. And at the very high levels, at the highest level of aggregation in that hierarchy, the data is very solid. But as you drill down into that data, you start seeing voids and gaps, and the data becomes sparse, and all of a sudden the analysis totally breaks down. And then the fourth example is when you want to overlap two data sets. Okay. Let's take a look at a simple year-over-year analysis. And I'm going to tell you right up front, whenever I get a question on doing year-over-year or period-over-period analysis, I do not show them this way. The instruction I give them is to use an LOD expression, and I'm going to explain why. In this data set, all we want to do is look at sales for 2017 through 2019, and we want to look at prior period. And that data set looks something like this. Okay, I'm going to open this up. And this data is a subset of the Superstore data that was shipped with your product. And it's a very simple subset. We're just looking at the three product categories over the 4-year period. It's a very tight data set, and it's totally solid. And when I join the two data, when I join the data to a copy of itself, I created a join clause that says that I want to match the year and the order date in this data set to the year plus 1, offsetting the dates by 1 year in the copy of the data set. And then we also wanted to join on category. And that works just fine with our very, very solid data set. As you can see, sales in the prior year matches the sales this year match the prior year, and so on and so forth. And we can extend that, and we can take it down to the quarter level. And we're going to open that up. And the join clause is much the same, but now that we're at the quarter level, we've added the quarter in one data set equals a quarter in the other data set, and we're still offset by 1 year. And when we look at that, data, sure enough, it's doing exactly what we wanted it to do. Now here comes the problem. This gets back to the real world problem of voids and gaps in the data. If we take the full Superstore data set and we try to make that connection, it gets very, very complex. And if it's not connected at the lowest level in the data, you end up duplicating data, you end up with nulls in the data, it becomes almost impossible to work with. And that's why I always suggest that people use LOD expressions. Okay. I'm going to go over to our second example now. This is a problem that we see probably 2-3 times a week out on the forum. Comes in a lot of different forms. It's when you have a data set that identifies a number of different programs or a number of different records, and each record has a start date and an end date, but you want to look across a total time period and see what happens in between. If you were like a bank manager and you had a portfolio of mortgages, you might want to know what your cash flow was going to be month by month from all of the mortgages in the portfolio. That's the type of problem we're dealing with here. Or the question that actually came into the forum came from an HR manager. And our HR manager had a number of different job openings over the course of a year. And for each one of them, he had a start date. He had a date when the job was open. He had a date when the job was filled. And what he wanted to do is he said, I want to know how many jobs I filled each month and how many jobs were still open each month. And he started playing with the data, and he was looking at, how do I get these things to match up? And there was no way you could get the two dates to match up. Now, if you had this problem and you didn't use Tableau, and you sat there and you said, well, what would you do? And the first thing you do is you say, well, I'm going to make a calendar, and then I'm going to put these jobs on a calendar. But he didn't have a calendar. There was no calendar in the data. So we had to make him a calendar. We made a very simple calendar. This was done on an Excel spreadsheet. All it is the first day of each month over the course of a year. Now we're going to come back to that calendar. Thank you, Tableau. We're going to join it with a very special join clause. Please open. Okay, there we go. A very special join clause. And what we want to do is we want every one of his records for each one of the jobs that he has open to match every month in the date scaffold. And we do that using what's called a Cartesian join. And a join clause is simply 1 = 1. And I know some of you have done this and done a lot. And it explodes the data set. Yes, it adds a lot of data into the data set. But now every record in this data set is joined with each record in that. And now we can come back and we can put the month of the scaffold on columns. And this is beginning to look like what we want it to look like. We want to be able to look across the months and see when the jobs were filled. At that point, we can write a relatively simple calculation. I'm going to blow this up and make it a little larger. And we'll get in, this is done with a LOD expression, which we're going to talk about in a few weeks. But this does nothing more than say, hey, look, if the month that the job is filled equals the month of the scaffold date, capture the job ID. And when we bring that to the table, we can now see, he can look across the data and say, well, yeah, here's a job that was filled in October. Sure enough, it's filled in October. And if he looks down all the jobs, he can get a total when they were filled and by month when they were filled. Now, his second question was just a little bit more complex. All he wanted to know is how many jobs were still open each month. And this would be the formula that you would write for that. And all this says is if the scaffold date is after when the job is open and if it's before when the job is closed, capture the job ID. And once again, we can bring it to the table and we can see, well, okay, here's a job that was open in October. It's still open, so it's open in October, November, December, and so on. And once we've done that, it's a relatively simple matter to total those up or chart them in any way that we want to. Now, his question came in, and I had a question like this morning, for example. He asked, well, what's the formula for doing it? Well, there is no formula for doing it until the data is structured properly. So here's a case where we had to restructure the data. We first had to figure out, well, what was missing? There was a calendar missing. We had to make a calendar. And we had to figure out how we were going to restructure the data on that calendar. And then we went back to using a join, in this case, a Cartesian join, to join those two data sets together. Okay, I want to go on to the next example now. And this example is a little more complex. This is another question that came directly from the forum. And it shows what happens when you have a data set that's part of a hierarchy, and it creates a hierarchy. And at the top level of that data set, the data is very solid. As you drill down, it's not. And for that example, we're going to use an inventory model. And I want to take just a moment and explain how that data is created and how it was created for our user. And it came out of his ERP system. That's a system like Oracle, or it's a system like SAP. And as I said before, those are transaction-based systems. They're collecting data as transactions flow through the organization. And the data we're going to look at is we're going to look at sales data. It starts at the sales invoice and totals to the total for the entire organization. And it's going to go along a hierarchy that's built inside the SAP system. This is built on the material master. When we look at that data, and where the data really comes from, it comes off the sales invoice at the row level. And that information is precise. We know exactly the customer who bought it, when they bought it, what SKU they bought, what the quantity was, and what the dollar value of that quantity is. So we know that data exactly. And all SAP is doing, or the ERP system is doing, is it's totaling that data as we go up that hierarchy. And at each level, the data gets more and more aggregated. It's still very accurate. It's totally accurate. We're just adding numbers together. But it also becomes less and less useful, because at the top of this pyramid, all we've got is we got a total quantity and a total dollar value. Now, if you've ever been in that type of environment, when you make a sales forecast, the sales forecasters provide a forecast. Usually, they roll the forecast every month. There's a new forecast made every month, and it rolls out 3 or 4 months into the future. And when you make the forecast, they always start with data that you know. And you start at the top of that pyramid with very accurate numbers, just the units and the dollars, and then disaggregated by product, by type, and finally by week. So the least accurate data is down at the bottom of that pyramid. And if we were to look, we'd start at the top, and then we'd break it down by product, and then we'd disaggregate it again, break it down by the SKU level, and finally we'd get around to putting a time dimension on it. His was in weeks, but it's typically weeks or months. And then, some seasonality might enter in here. Maybe you sell more in the summer than you do in the winter. But there's also very large customers out there, the mega marts, who buy very, very large quantities. They need it in a certain week. So you disaggregate it down to the week level. Now, when we're done with this data, that gets passed on to the next process. And the next process are the production planners and the purchasing agents who actually go out and they're buying materials, they're scheduling production, they're building, they're making product there and building up inventory. So we go from a very accurate, but not a real useful number, to a relatively less accurate, but a very useful number. And it's all paper at this point until we get down to actually making that inventory, and then it becomes a very precise number again. Well, because of the inaccuracy in the system, everybody involved with this knows that, hey, there's some chance that we're not going to actually make the forecast, and everybody uses the same metric. It's a very simple metric to calculate to determine whether you're on plan or off plan. And it's usually referred to as days or days on hand or days forward. It's all the same. All you do is you take the inventory, divide it by the average daily sales, and then you know how many days you have on hand, and then you compare that to what your expectation was. Well, that's where the question from our user came in. And the question came in and he says, look, I've got this very simple calculation and I don't understand it. He says, I know the data is accurate, and yet the numbers keep changing when I look at different levels of the data. And this is kind of like what he sent in. He had a lot more information, but we cleaned it up to make it easy. And all he wanted to do on the last day of the period, he wanted to take a look at the inventory level, and this number comes out of his SAP system or his ERP system. And so it's an accurate number. And then he wanted to calculate the average daily sales to determine the days on hand. And he said, I just don't get it. Well, we started looking at it, and we said, well, if that number's accurate, then what's this number? Where does that come from? And we're going to take a look at that calculation. And this is what he was using to calculate his average daily sales. And this is a table calculation, and we're going to do that a few weeks down the road. But all this table calculation does is it says, I want to take a look at the current record of the 6 that preceded, and I want to take the average of those sales over that time period. So I got 7 records. Those are my average daily sales over the course of a week. Well, if we take a look at what his data actually was, he had filtered it so that we were only looking at the last date. But if we take a look at what the data actually was, and we're going to look at company B here, that 7 record period wasn't 7 days, it was 17 days. So what he thought he was calculating for average daily sales wasn't anywhere close to being an accurate number. And if you take a look at what the data itself and force that data to show all the records that were available for the actual 7-day period, you can see the inventory and the sales record, it's just full of voids. It's sparse data. Well, The solution that we chose for him, because of his situation and what he wanted, was to go back and fill those voids in the data. And we do that with a date scaffold, very similar to what we did on the prior problem. But now it's getting a little bit too complex to do it in Excel, although you could do it in Excel. I went out to prep and I created 2 files. One was all the dates in his file, and the second was all of his customers. And we joined those 2 files together right here, once again with that same Cartesian join, 1 equals 1, and we blew that data set out to 336 records. That's at this point. Then we took this ladder that we created and we joined it to his original data. Okay, and a second join, and that's what's happening right here. And in that join, where we connected the 2 data sets together, we took all of the records coming from here and joined them to the records that he had in his inventory sheet. And now, when we brought the data back and looked at customer B again for that week period, we're looking across an entire week. We've used a ZN function to place zeros in where there were voids before. And when we calculate using that same calculation, and believe me, I tried to get them off this calculation, but using that same calculation, we see that he actually had 66 days worth of inventory. Okay, so we'll take a step back and take a look at what we've got here. The member that wrote in the question was a subject matter expert, and he's excellent at what he does. He's very, very good at what he does, but he didn't really understand that the data that he was working with was created by his ERP system, and it had voids within the data. And as long as he looked at the high end where he created the model, he was getting real good numbers. When he drove down deeper into the data, he wasn't getting good numbers at all. And the solution was to go back and to restructure his data using, once again, a Cartesian join and then another join, but we had to restructure his data. And once the data was in the proper structure, we were able to get him the answer that he needed. We got one more quick example that we're going to look at. And this came in really just a couple of weeks ago. We had a user write in and he says, look, I've got a series of people and I have their age and I want to break them into 3 groups. And the groups I want are the age group 20 to 30. I want to look at age group 25 to 35, so we're overlapping those age groups, and then 35 plus, and we were overlapping there. This question, I don't know how to do it. He says, I can't, I've been writing if statements and case statements, and I don't know how to join, I don't know how to get those 3 groups because of the overlap. Well, I'm going to open up the data set here. As a general rule, and there are people that may disagree with me, as a general rule, if you're going to use the same data twice or more than twice on the same analysis, and you're using it for different purposes, think about creating a copy of that data set and unioning it to itself. And that's what we needed to do here. We took his data set, made a copy of the data set, and dropped it on this union, and we made a union back to itself. And when you do that, the first data set carries with it the data set name. The second data set, Tableau, will append a number or a character out here. So you can see the 2 different data sets, and we've got the table name here, the original data set, and the copy of the data set. Once we did that, we now, whoops, didn't want to copy that, just wanted to look at it. Okay. Once we did that, we were able to write a calculation like this. And all we did is take a look and use the first data set, the original data set for the under 30 age group, and that same data set for the over 35 age group. And then I used the second data set. This is the copy of the original data set for the 25 to 35-year-old age group and created 3 groups that way. When you do that, you create a lot of nulls. You just filter out the nulls, and now we can look at the 20 to 30, the 25 to 35, and the 35 plus, and we can see that sure enough, Mary is in both, and John is in the 25 to 35 age group also. Okay. When you think about what we did today, we took a look at the 3 different ways that you can connect data, either using joins or unions, or by blending data. We took a look at some use case examples, and we took a look at some cases where you didn't really, the data was not in a structure where you could actually solve the problem or the question that was being asked. We had to step back a moment and say, well, what's needed? What's missing? And why won't this data work the way that it's structured? Then we had to restructure the data, and in restructuring the data, we ended up either making copies of the data or doing things like bringing in a date scaffold or a calendar and joining that back to the original data set. That's pretty much what I wanted to talk to you about. And Nick, if there's some questions out there, I'll try to answer them.